Alright, we are on problem number 13, section 13.4, the second derivative test. We have a composite function, y equals x squared plus 7x plus 10 squared. So let's take the derivative. Composite function, we're going to use the chain rule. We're going to take the derivative of the outside function first, times the derivative of the inside function, which is 2x plus 7. So now we need to factor this. We already pretty much have it factored in a way. So we just need to factor this quadratic term in the middle, and that's going to be x plus 5, x plus 2 times 2x plus 7. So the critical values are x equals negative 5, x equals negative 2, and x equals negative 7 halves. Alright, in order to identify if these are maximums, minimums, or not, let's evaluate the second derivative. So we need to take the second derivative. So I'm going to use the product rule here. So we have the derivative of the first function, which is 2x plus 7, times the second function, which is 2x plus 7, plus the derivative of the second function, which is 2, times the first function, which is x squared plus 7x plus 10. Alright, so let's evaluate the sign of the second derivative for x equals negative 5. So this is going to be negative 10 plus 7 is negative times a negative, so it'll be positive, plus negative 5 squared is 25, plus negative 35. So actually we've already identified these to be zeros of this function. So this thing is going to be a 0. So it's going to be plus 0, which means that this whole expression evaluated at negative 5 is going to be positive, which means it's concave up, which means that at the value x equals negative 5, we have a relative minimum. Evaluating the function at negative 2, we have negative 2 times 2 is negative 4 plus 7 is positive. Positive, so this is going to be positive. Plus, this is going to be 0. So we again have a function that's greater than 0. So it's positive, so it's concave up. And again, at the value negative 2, we have a relative minimum for the function, for the original function. And then finally, evaluating the function at negative 7 halves. Well, we know that's going to be a 0 for these expressions, so this is going to be 0, plus negative 7 halves squared, which is going to be 49 halves, plus negative 7 halves times 7, which is negative 49 halves. Sorry, this is going to be 49 fourths. Minus 49 halves plus 10. So let's turn it all into fourths. So plus 40 fourths. This is going to be 98 fourths. 49 minus 98 is going to be 49 fourths. Negative 49 fourths. Plus 40 fourths. Making this whole expression negative. It's going to be negative 9 fourths. And so that means it's going to be less than 0, so it's concave down. So remember, I don't actually need a value for the expression evaluated at the critical points. I just need to know the sign of it in order to then establish via the second derivative test if the function is concave up or concave down. So I've established that it's less than 0, negative, so it's concave down. So it's going to be a relative maximum. The function is going to have a relative maximum at the value x equals negative 7/2. That's all she wrote, folks. That's all she wrote.